4.1, variables and expressions. So keywords. So let's think about stopping the video now, writing down the addition, subtraction, multiplication, and division, and writing these down. They may come in handy later. If you feel like you're comfortable with them, that's fine, but I would have them as a resource to go back to. Certain ones I want to look for, first of all, is less than. Remember, that's that switch around word we talked about last year, and we'll talk about that again. More than is too, but really less than has to be because it's subtraction. Sum, difference, product, and quotient, answers to those problems. So an answer to an addition, answer to subtraction, multiplication, division. You want to look for the and sign because that's where you're going to put the operation. So those are just some little keys to help you. So for instance, to start, remember an expression has no equal signs. Equations have equal signs. So we're going to start with numerical expressions. They will have numbers only. We're not actually going to solve these. We just want to write the expression. So I do want you to write this first one, 8 less than 21. Now we're going to solve it. Again, normally you can go left to right, but less than is that switch around word. 8 is less than 21. So 21 minus 8. We're not going to solve it. That's our expression today. That is our answer. Remember, less than or more than, they need to be switched around. More than doesn't really matter because of the property that says you can add in any order, but subtraction you can't. So at this point, you don't have to write the words. Just look at it. The product, there's that sum, difference, product, quotient. So we go find the and, because they'll come in pairs, and 30 and 9. So that's where the multiplication would be. So 30 times 9. Last one, the number of 7 dozen donuts. So you have to think of, well, dozen means 12, and I have 7 of those, so 7 times 12. So you're going to do some with numerical, and then we're going to jump to algebraic. Algebraic now would mean that they have numbers and variables in them. So 14 more than a number x. Technically, you would say x plus 14, but you can actually write this one either way because the properties we're going to talk about tomorrow, but the commutative property says it can go either direction. All right, I'm going to let you do these next 3. Stop the video and then come back when you're done. Quotient. Quotient means divide. That's one of those 4 words. So there's the and. So that's where I'm going to put the division. With algebra, remember, it's the quotient of 3 and the number w. We write it as a fraction. Difference means to subtract. So the difference of 2 and, so 3 times a number p. The difference of 2 and 3p. Again, you could put the multiplication, but with algebra we try to leave those out. 1/4 less than m. Well, that needs to be switched. So m minus 1/4. Now you try again. Try 3 more. Come back when you are done. Sum means add. So this is a numerical. And we have 18 sum plus 35. 25 less than a number b, less than b, so b minus 25. Total means to add, so I have a number and r and 11. The total of a number and r and 11. So the total of a number, and r and 11. The way this one's written, and maybe I wrote it wrong, was a total of a number. So we'll use, I don't know, n for number, and r, and 11. We're adding them all up together. All right, real life. You plant a tree that is 10 inches tall. The height increases by 15 inches each year. Let y represent the years. So we take a look. If you plant a tree, it has to start somewhere unless you start it with seeds. So this would be an algebraic since we're using the y. So we have to start with 10. The height increases, there's my keyword, which means add, by 15 inches each year. So this is the one that's a little tricky. In the first year, it'd go 15 inches. In the second year, it'd be 30. And the third year, it'd be 45. So what I'm really doing is multiplying by the number of years. So let's see if that makes sense. If I put in 0, my answer would be 10, and that's where we started in. In the first year, if I times it by 1, it would get to be 25, which makes sense. So now what I'm going to ask you to do is find it in 9 years. So let's plug it in using substitution. 15 times 9, order of operations, is 135, plus 10 would be 145 inches in 9 years. Last one, go see if you can set this one up. Come back when you're done. Your friend has 5 more than twice as many tokens as your sister. Let T be the number of tokens your sister has. Write an expression for the number of tokens your friend has. So if my sister has as many game tokens as my sister, so she has the T tokens, twice as many means 2 times, and 5 more than. So again, I can go left to right. 5 plus 2T, or 2T plus 5.